Am I audible? I don't know what happened to my laptops. Something went wrong. So sorry for that. Uh, where we were. Okay, we were here for finding out the shear force. Okay. So, right. So now next step is to calculate the shear shear force in the gantry girder. Okay, and so we know in our gantry girder what was our span of the gantry girder was 7.5 meter. Then we had the maximum shear force we have to calculate now, right? And we know the maximum shear force will be here somewhere. Okay, this is the gantry girder point A, point B, RA and RB are the reactions. We have already calculated the reactions. But still now on the gantry girder we will calculate the reaction RA and RB with the wheel loads. Okay, here placed at this. So the maximum wheel load we have calculated it to be 300.75 earlier in the previous step. You can see we had calculated the, okay, this one was our maximum, this one for factored load on each wheel. So this is the factored load on each wheel, 300.75 kilonewton. So that if we see in our shear force in the gantry girder, this is the wheel 1, wheel 2, 300.7 with the weight of 300.75, 300.75. The wheel base was 3.5 meter on the this one above the gantry girder, and this the gantry girder load we have already calculated in the previous step, that is 2.85 kilonewton per meter. So and this distance we can find out by subtracting this wheelbase from here, 7.5 minus 3.5. Whenever we are finding out this shear force, the calculation of the shear force, we know the maximum shear force will be here at the corner, because your wheel, because this is your gantry girder, this is your crane girder, and here you have the trolley. Okay, so here these two are the wheels, here one and here one, this one. Okay, here is one wheel, here is one wheel, here is here. So we are, this is our gantry girder, this one. This is our gantry girder, and above that we have these two wheels, and your shear force is maximum when it is at the support. Okay, so our wheel base is here. Okay, maximum shear force is here at the support, so our wheel base we have placed here, and we are trying to calculate now the maximum shear force. So once we know this, we can calculate RA and RB, taking moment about B. What we'll get, RA into 7.5 minus this 300 into this total distance 7.5, then again 300.75 into this distance 4, plus we have this UDL 2.85 into 7.5 whole square by 2. So we got our RA to be this much. Okay, RB also you can calculate, but we know that the maximum load will be here at the point RA. Okay, our maximum load will be here. So we got our maximum load RA to be 471.8375. Maximum shear force, that means this is our maximum shear force, which is RA, the reaction. Then once we know the shear force, maximum shear force, what we can do, we can find out the surge load, because I told you that irrespective of other than the vertical loads, we also have different types of loads like surge loads, the horizontal, that means this is the surge load, And the braking load was on the gantry girder along the rails. Yes or no? And we had the surge load was along this side. That means with the trolley. Okay, so the total surge load, if I show you at the very beginning of the class of gantry girder, I told you this thing, this one. For vertical load, this one was how much? 25% of the maximum static wheel load we take if it is electrically operated. And if it is hand operated, this much we take. And now for the horizontal force, how much we take? For the horizontal forces transverse to the rails, we take it to be 10% of the hook load. This one, and the weight lifted on the wheel. That means the weight of the crab, that means the weight of the trolley, and the weight lifted. That means the hook load. So that will be how much? If it is electronically operated, it is 10%. If it is hand operated, then it is 5%. That is, this is the surge load is nothing but the horizontal force, which is transverse to the rails. If you, I told you, right, this side was our gantry girder, this side here was the crane girder, this side, and our trolley will also move in this way. So this is the surge load which is transverse to the rails. That means this way with the trolley, the movement of the trolley on the crane girder. Okay, so that is transverse to the rails. Total surge load is taken to be 10% here. Now the surge load is taken to be how much here? 10% of the hook load plus the grab. This one, or the crane capacity you can see. So total was how much? This is the load of the crane girder, maximum capacity of the crane girder's weight, and this is the crab, that is the trolley weight. So 24. This will be 10% of this load, 240 will be how much? 24 kilonewton. 10% of this 240, 24. So surge load on each wheel will be how much? On each wheel, because there are 4 wheels, right? So surge load on each wheel will be 24 divided by 4. We got it to be 6 kilonewton. This one, 6 kilonewton is the surge load on each wheel. Now the factored surge load will be how much? 1.5 into 6 we know. So the maximum bending moment due to, okay, now once we know the surge load falling on each wheel, okay, so what will be our, similar to this, the maximum bending moment due to the surge load by proportion will be how much? For the maximum wheel load which we had calculated, this was the maximum wheel load 300.75. For this maximum wheel load, we got our maximum bending moment to be 681.85, right? So now the factored load which we got is total surge load, factored surge load we got to be 9 kilonewton. So that means if for 300.75 we got it to be 681.85 maximum bending moment. So for 9 kilonewton, how much can be your maximum bending moment by proportion? We get it to be 20.40 kilonewton. Okay. So now once we get this, we have calculated the surge load. Now also one more load was there, which was what? Which was the braking load, which is this thing. This one was transverse to the rails, but this is longitudinal horizontal braking force, which is parallel or along the rail sections. Along the rail sections. So total braking load will be how much? 5% of the static wheel load we have. Again, if I show you. Again, if I show you here, this one you see horizontal force along the rail is how much to be taken? 5% of the static wheel load for both the electronically operated as well as hand operated cranes. Okay, so 5% will be how much? This one surge load we have calculated now. For the horizontal force along the rail, which is the braking load, is 5% of the static wheel load. So 5% of the static wheel load means how much? Static wheel, the load on each wheel was how much? 160.40. Okay, so two wheels on each rail. If I show, this was our suppose crane girder. Here we had the sorry, this is the crane girder. This one was our gantry girder. These two are the gantry girders. These are your crane girders. Here we have the load trolley, right? So braking load is what? The load on this gantry girder due to this two wheels, because it is moving in this way. When they will give a brake, apply brakes, what will happen? There will be some impacts, and that impacts are nothing but the force which is along the rail section here, because above the gantry girder we have the rail sections where the crane girders are moving here. So here are the two wheels, and on each wheel we have got our static wheel load to be 160.40 kN. So for two wheels it is 2 into 160.40, and then that should be taken 5% of the static wheel load. So static wheel load is 2 into 160. That means actually it is this one, 2 into 160.40 into 0.05. That is nothing but our 5% of this static wheel load. So it comes out to be how much? This one, 160.40, sorry, 16.04 kilonewton meter. Therefore the braking load will be how much? The factory braking load will be obviously 1.5 into 16.40. So that is our 2NG 4.06 kilonewton. Okay. So this was our all the load calculations. That means first of all we have calculated the maximum wheel loads we have calculated. Then we have calculated the maximum bending moment. We have calculated the maximum shear force, and also we have calculated the different types of load which are acting, like the surge load, Then we have the braking load, the vertical loads we have calculated. Okay. Next, if we see, next step is what? Next step is our to, now since we know all the load calculations we have done the horizontal and vertical loads, calculated the factor loads, all the kind of loads. So now the next step is we will find out the section. Since we are designing the gantry girder, we will find out the section. What section of the gantry girder we are going to take? You know what is gantry girder already. This is an I beam which is laterally unsupported beam, right? Okay. So now to find out the section of the gantry girder, what you have to do is you have to know that the economic depth of the gantry girder is given by L by 12, where L is our span, and span we know how much it is, 7.5 meter. So that gives out to be 625 mm our economic, that means the depth which for the gantry girder, economic depth according to ASCO, this is L by 12 for the gantry girder, and so it is 625. We have calculated it to be 625 mm. So we can take it to be 600, because we may not get a depth of 625, we can get a depth of 600. So we can take it to be total depth of the girder 600. Okay. So this we can take it to be 600 mm. Okay. So now next is to since we are designing, right, and we know we have already calculated how much load is going to come horizontal, vertical, all different bending moments, etc. So now according to that we are going to find out for our design what will be our gantry girder, which section we are going to take as a gantry girder, such that they can support those bending moments, or they can resist or those loads. Okay, so for that economic depth, how much we have, how much it should be of a section, 600 mm. Now again the width of the flange should be how much, L by this one, L by 42, within the range of L by 42, L by 30, which is 7 point, we know already the strands already we know. Okay, so we have got our this thing, how much we have got, 1 minute, huh? Okay, so 187.5 mm to 250 mm. Okay, that means from this range to this range, that means how much we got, 180, this one, 187.5 mm to 250 mm is what we got for our bending moment. Sorry, the width, we can take the width of the flange to be, because we have this I section we have to take for our gantry girder, right? So this flanges, the width of the flanges will be how much, 187.5 mm to 250 mm. You can take this range. Okay, so now to know, we know the depth of the girder, how much, this much, 600 we took. Width of the flange, approximate values we know now, that what kind of section we can consider. So width of the flange, how much we have got, 187 point, within this range. Now we will calculate the section modulus required. Okay, what is the section modulus required? That is given by, let me do one thing. Actually, I am also busy, Arega, on this convocation, for this convocation part of your seniors. So I may be busy also. Okay, the second half I may not take the class. If I am not busy, I will be taking the class for the second half. Okay, so please give me your attendance from now. Stephanie,
Present, ma'am. Present, ma'am.
4, 5, 6, 7, 8, 9,
Present, ma'am.
8.
Present, ma'am. Remember, yes.
Yeah, please tell me your roll numbers. Okay, if I call you,
Okay.
9.
Yes. Remember 8. Present, ma'am.
Okay, 9, 10,
Roll number 10, present.
okay, 10, 11, 12,
Present, ma'am. 12.
14,
14, present, ma'am.
15, 17,
Yes, ma'am. 17.
18,
Yes, ma'am. 18.
19, 20,
Yes, ma'am.
20. Oh, 20, 19 or 20? 21, 21, 23,
Present, ma'am. 23.
24, 25, 26,
26 present, ma'am.
30,
Present,
30,
ma'am. 30.
31, 32, 34, 35, 36, 37,
36 present, ma'am.
okay, 37, 38,
37, present, ma'am.
38,
Present, ma'am.
39,
37, present.
okay,
39 present, ma'am.
38 present,
42,
ma'am.
okay, 42,
42
39
present,
present,
ma'am.
ma'am.
43,
43 present, ma'am.
45, 45, 48,
48 present, ma'am.
49, 49, 50, 51,
50 present,
okay, 51,
51 present.
52, 54,
Present, ma'am. 54.
okay, 57, Abdul Latif, 58, 60,
60 present, ma'am.
61, 63,
present, ma'am. 63
99,
Yes, ma'am. 99.
okay, 101, 4, 6.
Present, ma'am. 104.
Okay, 6, 8,
108 present.
9,
109 present, ma'am.
109, 11, 111.
109 present, ma'am.
Okay,
Present, ma'am.
113, 14, 118, 119, 120, 124,
Present, ma'am. 120.
120, 124, 133, 134, 134,
Present, ma'am.
Ma'am,
136,
134. 134
136.
present.
Present, ma'am.
143, 144, 145,
145 present.
okay, 149, 151.
Ma'am, 144. I mean 114.
Huh?
114.
114. Okay.
Ma'am, 124.
Okay. 60 is present. 7. Something is happening to my computer. Okay, rest I'll take in the WhatsApp group. 136. Yeah, present. What is happening to my display, man?